Okay, Assalamualaikum. Today, our group going to present about Google Maps. Okay, Google Maps is a web mapping service and mobile application that offers satellite imagery, street map, 360 panoramic view of street, real-time traffic condition, and route planning for traveling by foot, car, bicycle, and public transportation. It is one of the most popular mapping applications used worldwide, providing users with accurate and up-to-date information on location, direction, and traffic condition. The app also offers features such as Street View, which allow users to virtually explore location at ground level, and the ability to save and share location for easy access later. Overall, Google Maps help users navigate the world around them with ease and efficiency. Uh, the apps like Google Maps might use several different data structure to help users find the best route to their destination. For example, it use stack. Stack data structure could be used to keep track of the user's previous location, allowing them to easily navigate back to their previous location. Beside that, they also use queue. Queue is a data structure that can be used to manage incoming user requests for direction, ensuring that the requests are processed in order and all of the user receive direction in a timely manner. Next is linked list. Linked list is a data structure that could be used to store a list of nearby points of interest, allowing the user to easily find restaurant, gas station, and other locations that may be of the interest. Next is array list. Array list data structure could be used to store a list of possible route from the user's current location to their destination, allowing the app to quickly calculate the distance and estimate the travel time for each route. Next is there is also a tree. A tree data structure could be used to organize the route between different locations, allowing the apps to quickly find the most efficient path from the user's current location to their destination. Finally, it also have a graph. A graph data structure that could be used to model the road, highways, and other transportation network that the app used to calculate the best route between the two locations. Okay, who do you think gonna be the next presenter? Jeng jeng jeng.
Right, assalamualaikum. My name is Faris Nova, and so for now, I'm gonna present and explain how the application works, and also list all the application's operations. So these are just some of the on how the application works and what they provide. So Google Maps is a popular navigation app that provides users with real-time maps, directions, and other location related information. And these are the overview of how Google Maps works. So one of them is map and location data collection. Google collects location data from various sources such as satellite images, street views, GPS data, etc. And map rendering, Google Maps also renders the map for the requested location using the collected data. And also, they also provide traffic information where they provide real-time traffic information and suggest alternate routes to avoid traffic congestion. And also, they have navigation where they offer navigation services that help users find the best route from the current location to their destination. And here are other overview of how it works, such as local search. Google Maps also offers local search services to find businesses and other points of interest near the user's location. And personalization, Google Maps can personalize its suggestion based on the user's search history, location history, and preferences. And It also have reviews and ratings. Users can rate and review businesses, restaurants, and other points of interest to help others make more informed decisions. And last but not least, APIs. Google Maps also provides APIs that developers can use to integrate location-based services into their own applications. Right. So now for the operations involved in Google Maps, they also have search for a location operation where users can enter a location name, address, or point of interest to search for a specific location on the map. And also navigation. Once the user selects a destination, Google Maps calculates the best route to that destination, taking into account traffic conditions and other factors. And also get directions. Users can enter a starting point and a destination to get directions to a specific location. And last but not least, local search. Users can also search for nearby businesses, restaurants, and other points of interest using keywords. Right. For the next one, reviews and ratings. Users can rate and review businesses and other point of interest to help others make informed decisions. And personalization, as I said earlier, Google Maps can personalize its suggestion based on the user's history. And again, last but not least, for real, this time developer APIs. Developers can use Google Maps APIs to integrate location-based services into their own applications. Right? I'm gonna pass to my next teammate.
Okay, Assalamualaikum. My name is Aide and I will continue the presentation. Okay, one of the key factors that influence the selection of data structure in Google Maps is the needs of efficiency stores and process large amount of location data. The apps needs to store data on roads, highways, and buildings and other points of interest, as well as real-time data on traffic conditions, weather, and other factors that can affect navigation. To do this, Google Map use a variety of data structures, including the first one is about graph. Google Map use graph to represent the transportation networks that is used to calculate the best route between two locations. The node of the graph represent the locations, while the edge represent routes or other transportation link between those locations. By using a graph data structures, Google Maps can quickly calculate the most efficient route between two locations, taking into account factors such as traffic condition and road closure. Moving on to the next part is trees Google Maps. Google Maps also use three data structure to organize the road between different locations. For example, the apps might be the search tree to organize a list of possible routes based on their estimated travel times. Moving on to the list part, Google Maps use lists to store data on nearby point of interest such as restaurant or gas stations. By using a linked data structure, the app can quickly search through a large number of points of interest and identify the ones that are closest to the user's current location. The fourth one is about arrays. Google Map use arrays to store and manage data on a large number of locations. For example, the app might use an array to store data on all of the businesses in a particular city. By using an array data structure, Google Maps can quickly search through a large number of locations and identify the ones that are the most relevant to the user's search. And the last one is about queues. Google Maps use queues to manage incoming requests for direction from users. When a user requests direction, their request is added to the end of queue. The app then processes requests in the order that they were received, ensuring that each user receives directions in a timely manner. Move on to illustrate how these data structures are used. Let's look at an example on how Google Maps might calculate the best route between two locations. First, Google Maps use a graph data structure to model the transportation network between two locations. The nodes of the graph represent the possible locations that the user can travel to, while the edge represent the routes or other transportation links between those locations. Next, Google Maps use a tree data structure to organize the possible routes between two locations. For example, the app might use a binary search tree to organize the possible routes between on their estimated travel time or distance. As the user enter their starting location and destinations, Google Maps use a queue data structure to manage incoming requests for directions. The user's request is added to the end of the queue, and the app processes requests in the order that they were received. And finally, Google Maps use an array data structure to store and manage data on a large number of locations. For example, the app might use an array to store data on all of the restaurants in the user's current location. By using an array data structure, Google Maps and quickly search through a large number of locations and identify the ones that are most relevant to the user's search. Moving on to the part illustration, we decided to use queue operation. Okay, for the queue operation, as we know in software terms, the queue can view as a set or collection of elements as shown below. The element are arranged linearly. We have two ends, especially fronts and rear of the queue. When the queue is empty, then the both of pointer are set to negative ones. The real end pointer is a place from where the elements are inserted in a queue. The operation of adding, inserting element in the queue are called enqueue. The front end pointer is a place from the where the elements are removed from the queue. The operation to remove or delete elements from the queue is called dequeue. When the real points value is size 0.1, then we say that queue is a full. When the front is null, then the queue is empty. Moving on to the part illustration, as we can see, D is an empty queue, and thus we have real and empty set to 0.1. For the figure 2, we add 1 to the queue, and as a result, the real pointer move ahead by one location. In the next figure, which is figure 3, we add two elements. We add we add element 2 to the queue by moving the real pointer ahead by another increment. For example, this is a 1, and then we're moving ahead uh, after once. We put it 2 after that. Next, in the following figure, which is figure 4, we add element 3 and move the real pointer by 1. At this point, the rear pointer has value 2 while the front pointer is at 0 location. Next, we delete the element pointed by front pointer. For as you can see in the part of figure 5, as the front pointer is at 0, the element that is deleted is 1. Thus, the first element entered in the queue, especially once, happen to be first element removed from the queue. As a result, after the first queue, the front pointer now will be moved ahead to the next location with each one. So I will pass to my next presenter.
So, Assalamualaikum warahmatullahi wabarakatuh. So, I will continue the presentation. So, for the operation, we choose to pick Q. So, over here you can see there is a set of coding right here. So, I will explain you briefly about the coding itself. So, this coding I have several parameters, which is direction renderer, direction service, marker array, and step display and map. This parameter I use for displaying the road markers on the map. So for the briefly explanation about this coding as overall, so on the line 5th to 8th is about the remove existing marker from the map. So next one is to retrieve the start and end of the location. For the next part is to call the road method of direction service to calculate the roads. So at the last, you can see it is about the if the road is promises, it's a rejected display and alert with the error message. So right now, I will explain about how to explain about the part of estimation for the efficiency of the algorithm. So one of the example that I can give involving in Google Map is finding the best road between the two locations. So for the algorithm, find the best road between two locations. So the input is starting location and destination location. So its output will the best road between the starting location and the destination location. So to estimate the efficiency of algorithm, we need to consider the main factors that contribute to the running time. The first one is retrieving the start and end location from the HTML elements has a constant time complexity of O0, O1 since it involves accessing a specific element directly. The road method itself makes an API request to the Google Map Direction API, which is an external service. The running time of this request depends on various factors such as network latency, server response time, and complexity of the road calculation algorithm used by the Google. Therefore, we cannot determine the exact time complexity of this step. So the third one, updating the warning panel HTML element, setting the direction for the direction renderer object, and calling the show step function have a constant time complexity since they involve basic operation like assigning values and function call. So based on the analysis, we can conclude the following findings regarding the estimation of efficiency from the given code. The efficiency of the algorithm primarily depends on the road method, which makes an API request to the Google Maps Direction API to calculate the road between the start and end location. The time complexity of the road method cannot be determined without knowledge of the internet implementation. It relies on factors such as network latency, server response time, and the complexity of the road calculation algorithm used by Google. The step involving retrieving the start and end location, updating the warning panel HTML element, setting the direction for the direction rendering object, and calling the show step function have a constant time complexity and can be considered negligible compared to the road method. To improve the efficiency, implementing caching mechanism to store previous calculated routes and avoid unnecessary API requests can be considered. Caching can significantly reduce the running time by reusing previously obtained result instead of making repetitive API calls. So overall, the efficiency of the algorithm heavily relies on the network request to the Google Maps Direction API. To further optimize the code, it might be worth exploring alternative approaches or algorithm for road calculation that can provide faster results or minimize the number of API requests. So that's all. So for the next part, I pass it to Faris Alif Nova.
Right, Assalamualaikum back again. So I'm gonna present the existing applications code that my teammate has presented earlier. And I will identify the collection class and the interfaces used. So the JavaScript code uses the array class as a collection to store markers in the marker array. It also utilizes several interfaces from the Google Maps API, such as direction service, map, directions renderer, and info window. The direction service interface provides the route method to retrieve directions between specified locations, and the map interface is used to create a map instance and control its properties like zoom level and center position. And the direction renderer interface is responsible for rendering the obtained directions on the map. And lastly, the info window interface represents an info window that can display content on the map, such as step instructions. Right, that's all for me. Right, for the next final member, you can guess who he is, and yeah.
Yeah, it's me. Okay. Lastly is conclusion. In this project, the team explore the use of data structure and algorithm in computer application which focus on our apps lah, Google Maps. Next is we also discuss the various data structures and algorithm used in Google Maps. That's how we know that Google Maps also have many data structure that they use. Besides that, the team also examine the efficiency of algorithm used to find the best route between the two locations in Google Map and estimate its worst case running time. Furthermore, the team described the collection framework including the classes and interfaces and discussed some of the operation that can be performed on collection. Uh, Next is the team also emphasized the importance of selecting the appropriate data structure and algorithm for a given application, as this can have a significant impact lah on the efficiency and usability of the application. Overall, this project provide a broad overview of the use of data structure and algorithm in the computer application and demonstrate how they are critical to the success of the popular application such as Google Map. Siapa tak tahu kan? Okay, I think that's all from us. Masuk, 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 masuk. Masuk, 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 masuk. Masuk, masuk, tak apa, masuk, masuk. Masuk, 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 masuk. Alah, tak sporting lagi. Member saya tak sporting ya. Okay? Okay? Cukup ah, cukup. Okay? Thank you. Masuk, masuk, masuk. Tunjuk roti, tunjuk roti. Dia tak tahu.
Thank you.